Hello, algebra students. We're taking a look at linear inequality word problems. And so you should have your section 10.7 and 10.8 notes with this heading. So we're looking at the first problem with Roberto has $300 to spend the video game store where they'll sell both used and new games. And used games cost $15 each, and new games cost $50 each. And we're going to find two possible ordered pairs of using the games X, the used games X, and the new games Y that Roberto can buy. So defining our variables there, X for the used games and Y for the new games. The idea that he has $300 to spend tells you that he can spend $300 at most. And then we want to incorporate the cost of each into the equation. So translating that, the used games as X, and they're $15 each. And so that would give us $15 for each used game, plus the cost of $50 for each new game, Y. And of course, that has to be less than or equal to $300. Okay, now we're not incorporating any tax there, so of course we would want to stay under that $300, aware of that situation. All right, then before we can graph, we want to take that and put it into slope-intercept form. So we need to solve for y. To solve for y, you want to get your 15x term over to the other side of the equation with subtraction. And so we get 50y is less than or equal to negative 15x plus 300. Just kind of keeping it in y equals mx plus b form. And then, of course, solving for y, we want a coefficient of 1, so we're dividing by 50. And so that is going to give us y is less than or equal to a negative 3/10 x plus 6, just doing that arithmetic there. Then this is the inequality that we want to graph. So we want to take a couple seconds here and set up our graph. Of course, our x-axis is our used games, and our y-axis is our new games. And we're looking at how many. So we're just looking at a one-to-one correspondence with the lines. All right, and so, of course, with graphing, we want to start at our y-intercept. So I'm going to put a point at 0, 6, telling that from that b value of a y-intercept of 0, 6. And then to follow up graphing, I'm going to look at my slope, and that slope of negative 3/10 tells me to go down 3 and over 10. So I'm just going to count that out. And mark that on my graph. And then you would connect those with a line. And because we are dealing with an inequality, we need to think about shading. And we are shading where y is less. So again, referencing that y-axis, where do the y's get less? Well, that's downward. And so I should be shading the area below the line. And that is where the solutions to this inequality would be. So we want to look for two possibilities that would work for this. And so you're looking in that blue shaded area for two ordered pairs that would work. So, you know, you can just, you could pick two of each. So two used and two new. Or you could pick 6 used and 3 new. Any ordered pair that would fall inside that shaded area. Or in this case, because it's or equal to on the line, but of course if we were considering tax, then that line would not qualify. For the next word problem, we can see that Maddie has $500 to spend at the American Girl store, and dolls cost $100 each, and outfits cost $25 each. And we want to find two possible ordered pairs of number of dolls X and number of outfits Y that Maddie can buy. So again, our variables are defined for us. So we're looking at the number of dolls is our X or horizontal axis, and the number of outfits is Y or a vertical axis. We have the costs of each highlighted in the problem. And of course we have our limit to what we can spend. And so we want to form that inequality. So if the number of dolls is X, then the cost of those dolls would be 100 times X and of course we're going to add to that any cost of any outfits. That would be 25Y. And if she only has $500 to spend, then of course that cost has to be less than or equal to $500. Again, not taking tax into account. But before we graph to get those ordered pairs for the inequality that would work, we need to change that into slope-intercept form in order to graph it. So we want to solve for Y. To solve for Y, we should subtract 100x from both sides. And then to get the Y by itself, we're dividing everything by 25. When we solve that inequality, we will get Y is less than or equal to negative 4x plus 20. And this is the inequality we want to graph. So you might want to pause the video and just get your graph set up. You need a Y axis up to 20 because that's our y-intercept. And I just took the number of dolls out to 13. So again, if you need to, pause the video, get your graph set up. And then we're going to graph that y-intercept at 20. So that's 20 on the y-axis. And so again, that's that y-intercept. And then our slope is negative 4. So that tells me to go down 4 over 1 each time. So just kind of counting that out. Is down 4 and over 1. And then down 4 over 1. And I can follow that down to the x-axis. It gives me an x-intercept. Might have miscounted there. Let me double check. It's hard when I'm blowing things up here to write on it. Yeah, so we get a x-intercept of 5, 0. And you can follow that line down and just create your line. And then because we are dealing with an inequality, we want to shade on there. And so we're looking at less than. Where is the y less than? So refer to your y-axis. And where do the y's get less? They get less downward. And so we want to shade where those y values are getting less. And so that's below, which is kind of to the left of the line. And then you're asked for two possible ordered pairs, and you certainly could pick the intercepts here. You really can pick any two ordered pairs inside the shaded area. So, Maddie could buy one doll and 8 outfits. Or she could buy 3 dolls and 3 outfits. Any ordered pair that is in that blue shaded region would work. So the next word problem is a system of inequalities. So there's actually 2 inequalities in here that we need to consider. And this is more realistic to something that could happen that you're trying to figure out possibilities for, because there's usually more than just a couple of variables in a real life situation. So you have Corey planning to sell his homemade wooden toys at a local craft show. And airplanes sell for $20, trucks for $10. And so you're looking at that possibility. So we have airplanes for 20 and trucks for 10. And he can fit no more than, so we're looking at less than or equal to 40 toys in his car. And he wants to sell at least, so he wants to sell greater than or equal to $600 worth of toys. So I'm going to take a look at doing airplanes as my x. So no variables given to me in this one, so I need to define variables. So I'm going to say x is equal to the number of airplanes, and y is equal to the number of cars, or trucks rather. All right, and then looking at incorporating cost and how much money, so looking at the money inequality, that the cost or the price of the airplanes is $20, so he would be making 20 for every x, and he would be making $10 for every y or truck, and he wants to make at least $600. So that gives us that first inequality. And we can take that inequality and put it into slope-intercept form. So solving for y. And so we get y is greater than or equal to, and that would be negative 2x, kind of switching to slope-intercept form there, plus 60. And then we have the second inequality to deal with, and that is that he can fit no more than 40 toys in his car. So that means when you have the airplanes and the trucks, they have to be less than or equal to 40, or they're not going to fit inside the car. Again, putting that in slope-intercept form, we get y is less than or equal to negative 1x plus 40, or negative x plus 40. And we want to graph those 2 inequalities. So we want to take a look at graphing that system of inequalities. So looking at that graph, which is set up for us, our first inequality, y is greater than or equal to negative 2x plus 60. That means our y-intercept is at 60, so I'm going to put a dot where y is 60. And that slope is a negative 2, so that's down 2 over 1, down 2 over 1. Just going to continue that. You can just get a couple of dots and then do a straight line. It's a little easier for me on the iPad to continue my dots. It's or equal to, so that is a solid line. And for that inequality, the y is greater than, so my shading for that inequality should go to where the y's are getting greater. Now the y's are getting greater above the y-intercept, and so I have to shade above. I'm going to have to shade above and to the right. So for the next inequality, as we're trying to find that system, what satisfies both, the y-intercept is at 40, so I'm going to put a dot at 40, and that slope is a -1, so that's down 1 over 1. Now that inequality happens to be a less than or equal to, so I do want a solid line there, but my shading should be where the y-axis is less, and so looking at my y-axis, I should be shading below and to the left of the line. And so the idea is that what solves the system is the overlap, and the overlap of those systems, of those inequalities, is kind of that area in between here that I'm shading in light green. And then you're asked to pick two ordered pairs that work. So you want two ordered pairs that fall inside that shaded area, not using 0. And so, or you're asked to pick one ordered pair. And so I'd like for you to choose an ordered pair that would work. I'm going to choose, something that falls in here. And so bring that choice to class and we will discuss them.